Hey class, today we will learn about why you should care about hash tables. This video is the final part of a multi-part series on hash tables. If you missed the other ones, feel free to check out the playlist in the description below. Hash tables are very speedy. They can perform lookup in constant time, which is a lot faster than other data structures, such as arrays which require linear time lookup for key value pairs. Hash tables also allow you to write more modular and elegant looking code. Here I've written two functions in Python. They both do the same thing. Given the weather, they tell you what clothes you should wear, but the first one uses a series of else-if statements, and the second one uses a Python dictionary, which is implemented as a hash table. You can see that the version with the hash table looks a lot nicer, and if you want to add another weather condition, you can do so by modifying the hash table rather than adding a new else-if statement. Due to their constant time lookup, hash tables can significantly speed up code by caching, which is storing values calculated in your program that you might want to use later. Here's an example of a function that returns the nth Fibonacci number, implemented without caching. To get the nth Fibonacci number, the function does a recursive call on n-1 and n-2, and sums the two results. If we want to visualize the function calls to find the fifth Fibonacci number, it would look something like this. Each node branches off into more nodes until we reach a call on 0 or 1 at the bottom. This is unfortunately O of 2 to the n, which is exponential time. Here's another solution that uses a hash table instead. This time, previously calculated Fibonacci numbers are stored in a cache. So for example, if you wanted to call fib5, you wouldn't need to go through the whole branching recursion because the results of fib4 and fib3 would already be stored in the hash table. The basic idea is that you build the hash table from the base case up, rather than recursing from the final number down. This is an example of dynamic programming, specifically memoization. If you don't know what those words mean, that's totally okay. I just mentioned them in case you want to check out these concepts for yourself later. All you need to know is that hash tables can store intermediate values in a program. Here's a visualization of getting the fifth Fibonacci number using hash tables, where the blue box indicates that the function is pulling the value from the hash table. We can see that the runtime is O of n, or linear time. To show further comparison, I wrote some code to compare the speeds of the two programs and graph them. You can see that the two methods take a similar amount of time at the start, but then at around n equals 30, the Fibonacci function with the hash table starts to be significantly faster. One thing that I want to point out is that asymptotic complexity does not necessarily correlate with small input behavior, which is why the implementation with the hash table looks on this graph to be constant, even though we know it's O of n. Hash tables have many applications, and I want to share just a few of them. You can use hash tables to match words to definitions, menu items to prices, and authors to books. Hash tables are used extremely often in computing, including in databases, compilers, web caching, and graph algorithms. Also, I want to talk about job interviews. I feel like these kinds of things should be mentioned in courses more often, but data structures, and specifically hash tables, is an extremely common topic in coding interviews. So if you're trying to become a software engineer, you should care about hash tables because your knowledge on hash tables could make or break your job interview. LeetCode is a popular website for practicing coding problems. Not sponsored, by the way. I just want to point out that out of all the topics on the LeetCode website, hash tables are the third most common topic. So that should tell you how important they are for job interview preparation. The last thing I will briefly mention is when we shouldn't care about hash tables. Recall that a good hash function spreads the items uniformly across the hash table. This means that any order in your data will be lost, so if you want to maintain the order of your data, you should use a different data structure such as an array or a binary search tree. Well, thanks for watching everyone, and thank you for joining me on this hash table journey. If you missed the other parts, I'll link the playlist in the description. Feel free to comment any questions you have about hash tables, or any topics you would like me to cover next. I also welcome feedback for how I can improve my videos. As always, this is your CS Professor of Fun.